Well, hi guys and girls, Cam here at Battler. only taking the Mickey out, Emma. My name's Cameron. I have a small YouTube channel called Cam at Battler, and I've got a few videos up, and yeah, they suck. They're about fixing things rather than making things. My bandsaw caught on fire, so I've had to fix that. My hit and miss engine timing went up the creek, I had to fix that. Shelf door on my fridge fell out, I had to fix that. My shed sunk, so I've had to fix that. But hey, I actually get to make something this time, which is good. And what are we making? We're going to make one of these. They're called the Multifix or a 40 position tool holder. And I'm going to make a confession now. I've actually made a few of these in the past, back in 2012, 2013. So I didn't see where in the rules where it said you couldn't make a tool twice. So I hope that doesn't put me out the back door before I start with. These tools are fairly expensive to buy in Australia. They're about $200, which isn't cheap. You get two sizes in the particular size. I've got one at 22 in depth and the other one's 32 millimeters in depth. And the problem is when you want to put these little tiny boring bars in, you've got to pack them up a fair bit, which is a bit of a pain. So that's the job we're going with. The stock I'm going to be using for it is just a bit of old balloon, so we'll cut a length out to do the actual body, and then we'll cut a wafer out to do the tool post adjuster. I've done some proper drawings this time. I went back through my notes and had some old chook scratching, so I thought I'd better make it a little more professional. So I've done a general arrangement of the tool post holder, and I've done a detail sheet as well. So that's the mud map we'll follow as we go through the build. All right, let's get on with it. I'm not doing a take again, Rose. I've done that 10 times.
Okay, so we're just going to cut that off to length. Well, it's 100 millimeters by the drawing. We'll cut it off 103 and give ourselves a little bit of material to clean up with.
Alright, I'm going to come down to size now. As I said in the intro, because I do the design, I can make changes as I like. So rather than coming down to 41 millimeters square, I'm going to clean this up at 47 millimeters square. It's not critical, as long as all the dimensions that pertain to, for example, the sawtooth come off that face there. So the fixing points for the adjusting bracket, for the holes, everything is referenced off that. Everything for the slots referenced off here, so that if you change the size on that, it doesn't matter. The reference points will be the same for all those critical dimensions on that side. And something I always do when you're machining, I always just whack an X on where I've actually done the face machine. When you pick these things out, you flip it around your hand a few times, you don't know which face you've actually machined. So I always find just to put a cross on the face to say, yep, I've machined those faces. And what I've got left to take off, so I'm going to take 0.181 off the thicknesses on these, and that'll bring me down to 47. Well, hopefully 47. All right, we'll set this up, do the final machining, and we'll come back to you. Well, Emma, I think you're going to have to sack me, mate. We'll take points off me at least. I wanted to come down to a normal size of 47, but I machined the same face twice, so I've we get there 46.89, 46.9, 46.9, 46.95-ish, 46.94. So anyway, like I said, if I design it, I can make it whatever I like. So I tell you what, it's not easy trying to film and focus on what you're doing. It's so easy to make a mistake. Jeez. Anyway, we'll soldier on. It's not going to affect the end result anyway. But like I said, take some points off me, mate.
Alright, I'm just going to square this up in the vise and machine the ends off. You know, there's probably some machinist law that says you can't machine ends off like this. You have to do it with an end mill on the sides, but geez, I love breaking the rules. Here we go, I reckon that's pretty spot on there. There we go. Alright, we'll clean off the burrs and we'll flip it over and machine the other side to length. Let's see if we can actually hit a number this time. Alright, just to prove that I can actually machine something to a dimension. There we go. So I aim for 100 there, and look, that's pretty spot on. So my reputation is intact, I hope. So look, that's not a critical dimension, it doesn't really matter, but yep, I'm happy with that. The next job I'm going to do is we're going to mark this out, put a bit of bluing ink on this, mark out the crescent shape, and I'm going to rough that out, and then we're going to set the boring bar up and machine that crescent to size. So that's a fairly critical dimension. That's going to be fairly spot on. For when we cut the saw teeth, we want to make sure that the engagement into the mating part on top of the top slide is spot on. We don't want to have any chance of that wobbling around whilst we're actually doing the machine. We don't want to have any slop in that at all. So that'll be the next operation. So we'll get set up for that one. Alright, before I start marking this out, I might show you my long-suffering surface table. This is one of the very first eBay purchases I ever made. And I spoke to the guy over the phone and said, you know, what's the condition of the table? And he said, yep, it's pretty reasonable. I'll tell you what, it looks like it was owned by a blacksmith or a farrier who used to do horseshoes on it. It was just, it had ball peen marks and hammer marks and centre pot marks, and oh, it was an absolute mess. It's made by the Gauge and Instrument Company of Melbourne, and it's classed as an A grade. Well, it's certainly not an A grade anymore. Let you live and learn. One day I'll get this off to a workshop that's got a nice big reciprocating grinder or a big Blanchard that I can get that surface finished up on it again. It's yeah, I reckon if any of the big YouTube channel blokes had to work on this, I think they'd have a fit. I look at the beautiful granite plates that they've got, but yeah, a little bit out of my budget range. Speaking of granite plates, I actually chased up through, believe it or not, stonemasons who do headstones that do big granite blocks. You know, they're sort of like 3 inches thick, and I can get one made up for about $100 with all the holes bored in it, so that I can put lifting bars on it. So not too sure what the surface accuracy would be on it, but looking at them, they're pretty good. Well, they look pretty good anyway. So anyone who's can't afford a proper granite plate just for home hobby use, you know, maybe duck down to your local headstone place and ask them how much a granite block would cost you. Anyway, we'll set this up and we'll start marking it out. Righto, I'll try and stay out of the way of the camera if I can. Alright, I'm going to mark a centre line down through here, and a reference point from that edge there, we're going to come back, looking at my mud mat, 19.4 millimeters, and the scratch line is 36.4. I'm only going to go 35. It's only for roughing out, the guide for roughing out. When we do the actual bore, I'll clock up the centre of this and we'll go off the digi readout to get an exact dimension on that. So I'll just set that up about 50. I'm not sure if you're allowed to do it like this. Use the jaws of the digital calipers to mark a line. Well, we all do it, don't we? Should really centre pop that, but I'll try and avoid that if I can. Alright, we'll go and get that set up in the milling machine, and we'll get that clamped up and start roughing it out. And we'll start the boring head operation to get the semicircle done. Righto. Alright guys, we'll get this set up for cutting this crescent out. To save a lot of time clocking jobs up every time, I've made up a number of these, I call them tenon blocks, that are really snug fit into the T-slots, and you can butt work up to it. As I said, it saves you having to clock stuff up. You know that part is dead true to the table. Well, it has to be dead true to the table. So we can push it up nice and hard against it. I've got it sitting up on parallels so that when the cutting head comes down, it's not going to hit the table. I'm just going to make sure the parallels are out of the way as well, and they're not going to get hit when that cutting head does come down. I've got one of those mongrel little splinters in there. Try and get that thing out. It's one of those ones that every time you touch it on something, it really stings. Joys of working in a machine shop. Alright. So that's done. We'll get a cutting head in there, and we'll get set up. Alright, for hogging that in, start the cutting operation of this now, the hogging out. I'm using one of these cutting heads which has got the round inserts. I picked these up, I think it was one of the Chinese supermarkets I picked this up, Banggood or somewhere like that, and it's just so cheap, and you get the inserts with it as well. But it's good because of the way that it's overhang, you can actually plunge right down and have the clearance to hog this out. So we'll start that operation now. I've already started a little bit, but let's see how we go. Fantastic, very universal machine, but rigidity is not one of their strong points. What I'm going to do now is need to get the head central to the body and in line with that edge. So we need bang smack in the middle there. So we'll just use our little edge finder, and we'll get that center point done first. Right, next thing I need to do is set up the radius swing of the boring head. So we'll set it up and use that as a datum face. So I'll get that set up in the quill, and we'll come back to it. Righto. So we've got the head in there. I'm using one of these little brazed in carbide insert tool holders. I don't like them. Whenever you buy these, you've got to reset all the clearances on them. You've got to regrind all the clearances because they aren't real flash. I don't think the carbide's real good either. They tend to chip really easily. So they're only very cheap things to buy. Right, so what we need to do is we need to basically set up a radius of 36.4. So from the centre line of the quill, 36.4. So we know that the head is bang on that edge there. So if we crank it back on our digi readout, I'm getting some of the head. Right, so that's 36.4. So what we can then do, just bring it across a little bit and just wind it in and out until we just get that touching on the surface. Might make it a little bit easier. I might bring the quill down for this a bit. So I'm going to bring that in just a little bit further. It's just touching there now, guys. Alright, let's bring this back to 0. That's pretty close. Put the quill back up. Right. The drawing also shows us that we have to be 19.4 from the edge to the centre of the quill. So we'll bring that in now. Oops. So we're exactly on centre line. We're 19.4 from that edge, and we've set our radius at exactly 36.4 by doing a little scratch on there. So, alright, so I'm going to zero out that 19.4 because that's going to be where we want to come to. So we're just going to creep up on that with our y-axis, just bring that up until we get that sitting at 19.4 for our final cuts. I did give this tool a good hone with the green coil stone. Put a good edge on it. It's got about a 1mm radius on the tip. Oh, it's beautiful. And that's it. We're done the sides. That's it there. Beautiful finish on that. No vibration at all. So the next step is going to be setting this up on the rotary table in preparation for cutting the teeth into this. So we'll get set up with that next. And I've got a special head that I've designed and manufactured for sliding that I can mount directly onto this quill with my milling machine. I've got it hard up into the corner, so I've got no room to be able to put a traditional slotting head on the back of this ram. So yeah, I've got one that I've designed up that mounts directly on the quill here, and I can do slotting, or I've got another adapter that I can mount on up to do shaping. So we'll get that set up tomorrow, and we'll have another crack at that after work. Alright guys, we're back again. Just to save a bit of time, I've actually preset this up on my rotary table, and I've clocked the back face, and I've got that 0 zeroed. I've also set that edge up against the tenon in the T-slots and got that spot on. So that's my cutting tool that I'm going to be using. I think it's 100 degree. I'll have to go back in my drawing and have a look. But so far, as I said, we've got the back squared up. I found the mandrels I made up for this years and years ago. I've got an adapter I sit down inside the Morse 2 taper that's in the bottom here that I machined up. And I machined up an amble that's a really tight fit onto that parallel section of that bar. and that basically allows me to set the crescent dead central to the table. So crescent's dead central to the table. It's now dead square. I've taken the backlash out of the rotary table, so we should be pretty right to go. Next thing I'll do is I'll just center that up to the center of the block, and we'll start getting those grooves cut in. So this is a little vertical slotting head that I made up. So I just basically did a retrofit on this little Gem Power right angle head, so I do a fair bit of machining to that and make up a body and make up a swash plate inside. It's infinitely variable from 25mm up to, I think it's 76mm I designed that up to. So it just works off a crank and a slide arrangement, and does what a slider does, goes up and down. So it works really nicely. I also made up another head for this so that I could actually slot. So if I find a picture, I'll put it up. There we go. So that's slotting at about 55mm there, so it's got another 25-26mm that can slot to. So that's the head.